talked about the upsides of pharmacologically boosting GLP-1 activity in terms of weight loss, given the ravages of obesity, and I've also discussed its downsides, including common gastrointestinal reactions and muscle loss, as well as the rarer and more speculative side effects such as thyroid cancer, pancreatitis, and pancreatic cancer. And I've summarized the cost-benefit trade-off, detailing for whom the benefits may far outweigh the risks, at least in the short term. But is there any way to get the benefits of GLP-1 without the risks, by boosting it naturally with diet and lifestyle changes? Well, there's exercise appears to acutely increase GLP-1. There have been 5 studies of exercise and GLP-1, and 4 out of 5 of them found higher concentrations of total GLP-1 after high-intensity interval training and sprint interval training, as well as moderate-intensity continuous training, with no apparent difference between high-intensity interval and moderate-intensity continuous. Compared to control groups where the study subjects didn't exercise at all, both types of physical activity, high-intensity interval and moderate-intensity continuous, induced significantly higher GLP-1 concentrations immediately after exercise and 30 to 90 minutes later. Unfortunately, there appeared to be publication bias, meaning some trials that failed to show an effect may have been quietly shelved, thereby skewing the results. But what's the downside of exercising? The evidence is overwhelming that nearly everyone can benefit from becoming more physically active. What about diet? There are a variety of natural products, foods, beverages, and spices that have been shown to boost our own natural GLP-1 levels. But can endogenous GLP-1, meaning GLP-1 from inside the body, work as an alternative to the drugs that mimic GLP-1, like Ozempic? If you haven't yet, I recommend watching or rewatching my video about what GLP-1 is and how it works to best fully grasp the issue at hand. Our natural GLP-1 levels rise and fall in response to meal ingestion. When we take these drugs, though, levels in our blood remain relatively constant and high. But high here is a bit of an understatement. The total concentration of these GLP-1 lookalike drugs in our bloodstream is typically around 20 to 30 nanomoles per liter. OK, here's how much GLP-1 rises naturally in our bloodstream in the 2 hours after we eat a meal, up to maybe 20 or 30. Picomoles. Nano means billionth, pico means trillionth. So at this scale, drug levels are up to like 25,000. How could boosting natural levels even come close? Well, part of the discrepancy may be an artifact of taking blood from people's veins to do blood tests. Since natural GLP-1 is rapidly deactivated by an enzyme in our blood, by the time GLP-1 is secreted by our gut, makes it through our liver, heart, and lungs, then out into our arteries, only to later reach the veins where the lab tech is pulling out the blood, the levels we see are lower than the arterial levels that GLP-1 receptors are exposed to throughout our body, though only by a relatively small amount. But how do drugs like Ozempic sit around the body for weeks instead of minutes? They're chemically modified to stick to the most abundant protein in our blood. So even though the total drug level in our blood is up in the nanomolar range, it's so tightly bound to protein that the active level in our blood, that's free to actually interact with tissue receptors, is like 100 times smaller, at least down in the picomolar range. Thus, although at first glance it appears that plasma drug levels are extremely high, they actually may be closer to those of natural GLP-1 levels after strong stimulation. But still, there seems to be a huge discrepancy. It's GLP-1 activation in the brain that appears to account for the regulation of food intake, but it isn't currently clear how this might be related to GLP-1 in the blood. The primary source of GLP-1 secretion in the body is the gut, so wouldn't it get eaten up by enzymes in the blood before much of it even made it into the brain? It can cross the blood-brain barrier, but is enough really getting up there? Well, GLP-1 is also produced by nerves in the brainstem itself, and a large body of evidence points to the appetite-reducing effects of GLP-1 mimicking drugs like Ozempic being mediated by these brain GLP-1 receptors. So how could natural blood levels, expected after dietary interventions aiming to increase the secretion of gut GLP-1, still have clinically relevant effects? Yes, the GLP-1 released from our intestinal cells is rapidly degraded, leading to low systemic levels, but its effects appear to be mediated by vagus nerve stimulation. The vagus nerve connects the gut straight up into the brainstem, so it's directly wired to the brain and doesn't have to rely on blood transport. But wait, there are GLP-1 receptors on the pancreas, the kidneys, the liver, the heart. Why would the body have GLP-1 receptors on our peripheral organs if the hormone acts mainly through the vagus nerve? It's possible that strong stimuli can boost levels high enough in the blood to activate these peripheral receptors. So perhaps the way GLP-1 normally works is that we eat a meal, and GLP-1 sends the appetite-reducing signal to our brain directly through the vagus nerve, and then our brain relays the messages to the relevant systems throughout the body. Injecting people with high levels of a GLP-1 mimicking drug like Ozempic means it can circulate directly through the bloodstream to all these organs, including the brain, and a strong dietary GLP-1 stimulus might be able to do both. But you can't really know whether natural physiological levels of GLP-1 can suppress appetite until you put it to the test. When different levels of GLP-1 are dripped straight into people's veins, you can see a dose-dependent reduction in both hunger and food intake. OK, but effective doses used in infusion studies quadrupled baseline levels or more, whereas the blood levels increased by GLP-1 boosting foods tended to only double baseline levels. So while high-dose GLP-1 infusion drives a clear change in hunger and eating behaviors, is it possible that inducing GLP-1 secretion through diet may not? Well, remember how food naturally only boosts blood levels up around 20? It turns out you can get a significant drop in food intake, up to 30 to 35% less of an all-you-can-eat meal, simply by getting your GLP-1 levels up to 10 or 15, or even just 5. That is well within doable dietary ranges. So while low natural levels might appear to have little effect at first glance, a slight increase in levels by dietary manipulation of GLP-1 secretion could be sufficient to have clinical relevance. Thus, we don't have to strive for levels comparable to those obtained using drugs. And of course, this makes sense, right? Why would our body naturally produce an appetite-suppressing hormone in response to food if it didn't end up suppressing our appetite? This review on boosting the hormone GLP-1 by natural products concluded that there are compelling studies that suggest that the berberine in barberries, quercetin in capers, red onions, and buckwheat, ginseng, ginger root, gardenia, green tea, wheat fiber, soybeans, curcumin and turmeric, cinnamon, and resveratrol in grapes each have potent effects on GLP-1 activity. The hope is that increasing the release of our own GLP-1 hormone by eating specific foods could have similar benefits to GLP-1 mimicking drugs without the potentially disabling side effects. But anytime a review makes a statement of fact, like potent effects on GLP-1 activity, it's always important to dig up the original studies, the so-called primary literature. For example, here's the section on soy. Researchers demonstrated that soybeans can normalize blood sugars by inducing GLP-1 secretion. Dietary consumption of soybean protein induces GLP-1, and moreover, soybean protein increases GLP-1 expression and secretion. This combined evidence strongly suggests that soybean protein exerts modulatory effects on GLP-1 secretion. Sounds great, but if you pull these three sources, that was based on studies on mice, rats, and in petri dishes. Gardenia-derived products also purportedly potentiate GLP-1 secretion based on cells and rodents, but when actually tested in humans, those in the gardenia group actually showed a decrease in GLP-1. Evidence also suggests ginseng improves GLP-1 secretion, but again, that's just evidence from rats and test tubes. What about that red wine compound resveratrol? Works in diabetic rats, but not in diabetic humans. Green tea is said to increase GLP-1 levels in actual patients, actual human patients, but in fact the increase over placebo did not reach statistical significance. Olive oil is said to induce higher GLP-1 concentrations than butter, but the study that was cited, this one, actually showed no significant difference. This was on healthy subjects, though. A similar study on those with diabetes did show a larger GLP-1 response, though only by about 15%. Avocados have lots of monounsaturated fats too, and online you'll find so-called experts who claim that eating avocados can be as effective as getting weight loss injections. a food that works just like the miracle weight loss jab Ozempic. And that's from a nutritionist. Ozempic may work if you're a rat, but in humans, GLP-1 was found to be significantly lower in the avocado-added meal. Speaking of online speculation, what do we know about berberine, the supplement dubbed nature's Ozempic, a component of barberries, a dried fruit I've previously profiled as a treatment for acne? Well, berberine boosts GLP-1 secretion in rats and petri dishes, but there haven't been any GLP-1 studies on humans yet. What we care about, though, is weight loss, and there have been a bunch of studies on the effects of berberine and barberries on body weight. No effect was found, either for berberine supplements or barberries themselves. This is all very disappointing. Something in the spice fenugreek seemed to boost GLP-1 signaling in a test tube, but there are no human studies. And it didn't even work in mice. So fenugreek flopped, but there are some spices that can legitimately boost GLP-1 in humans. If you have people eat the same meal, but chew each bite, either 15 times or 40 times, the blood levels of the appetite-suppressing hormone GLP-1 in the bloodstream are higher after 40 chews than 15. And those who chewed 40 times ended up consuming about 75 fewer calories than the 15-time chewers. The researchers suggest that chewing more may help people keep their weight down. OK, but who wants to sit there and count how many times they chew? What if you just eat chewier foods? What if you have people eat shredded cabbage, which requires a lot of chewing, or the same amount of pureed cabbage, same food, but requiring different amounts of chewing? GLP-1 blood levels were higher in the shredded cabbage chewing group than the pureed cabbage non-chewing one at 45, 60, and 90 minutes, at least initially. The researchers were careful to make sure both groups ate at the same rate, because eating even the same food more slowly can result in a greater GLP-1 response. Researchers had people eat the same amount of ice cream over a period of either 5 minutes or 30 minutes, and those who ate the exact same amount of the same food more slowly experienced a significant boost in GLP-1 levels in their blood for hours after the meal, about a 30% bump overall. On average, the participants were overweight, but a lot slimmer than your average American. What about essentially redoing the same study, but with obese individuals who could really use the extra GLP-1 boost? And here we go. As you can see from the title, the researchers found disparate results when they tested obese adolescents versus obese adults. With the obese teens, researchers saw the same outcome as they did with the overweight adults, a significantly higher GLP-1 response after slower eating. But the rate of eating didn't seem to matter in obese adults. Same thing with satiety. Obese adolescents felt fuller, more satiated for longer when eating more slowly, but speed of eating didn't seem to matter in the adults with obesity. But at least for some, more chewing and eating more slowly may raise GLP-1 levels no matter what's consumed, but are there certain foods that specifically boost GLP-1? There are a few spices that might. Volunteers were served rice with vegetable curry made with 3 different doses of spices. The bland control meal had no spices at all, just tomato puree with eggplant. The low-spice meal added a tablespoon of curry spices, plus onions, garlic, and ginger. And the third variation, the high-spice curry, had double the spices, 2 tablespoons. The spices were turmeric, coriander seeds, cumin seeds, dried Indian gooseberry powder, also known as amla, cayenne pepper, cinnamon, and cloves, mixed in the ratio of 8 to 4 to 4 to 4 to 2 to 1 to 1, respectively. And the average bump in GLP-1 blood concentration for those eating both the low-spice and high-spice meals were 17 and 32% higher compared to the bland control meal without the spices. About the same calories and macronutrients, but the spicier meals raised GLP-1 levels higher. But which spice was it? Ginger compounds boosts GLP-1 in mice, but not rats, and in humans, we appear to react more like the rats, no effect. For many of the other spices, there isn't even in vitro data, but rather only in silico, meaning just some kind of computer modeling that didn't actually test anything in a biological system. But we do have data on curcumin, the yellow compound found in the spice turmeric. This study used 180 milligrams of curcumin, which is the amount found in a single teaspoon of turmeric. The researchers also tested fish oil supplements, but while the fish oil failed, the curcumin reduced the blood sugar spike after a meal, which is something both GLP-1 and GLP-1 drugs can do, though GLP-1 levels weren't directly measured. The researchers suggest it may be a GLP-1 effect, since curcumin stimulates GLP-1 in rodents, as well as cells in a petri dish, but there hasn't been a human study until now. 6 months of curcumin supplementation led to a quadrupling of GLP-1 levels compared to placebo. OK, so turmeric may help. What about cinnamon? Scandinavian researchers gave people rice pudding, with and without 1 or 3 grams of cinnamon, which is about 1/3 of a teaspoon or a full teaspoon. And those getting the full teaspoon of cinnamon more than doubled the GLP-1 bump from baseline compared to the controlled pudding without the cinnamon. So that's another spice that may work, though people didn't report feeling any more satiated eating the cinnamony pudding compared to plain. And finally, the third spice to boost GLP-1 in humans, cayenne pepper. What happened when half a teaspoon of cayenne pepper was added to a meal? Over a short period of time, 15 minutes, a single spicy meal significantly increased blood levels of GLP-1, though like in the cinnamon study, this did not appear to translate into them feeling any fuller, but the researchers didn't measure actual subsequent food intake. Most of the poisons used by humans come from bitter plants, for example strychnine and hemlock. At the same time, some of the most popular beverages in the world are bitter, as are some of the healthiest foods. Bitter taste receptors aren't only on our tongue, but throughout much of our digestive tract, on the very same cells lining our gut that secrete the appetite-suppressing hormone GLP-1. And indeed, a number of bitter compounds have been shown to potently stimulate the release of hormones like GLP-1 in petri dishes and lab animals. What about people? And beer. Beer is one of the most popular bitter beverages thanks to hops. Given that bitter herbs have evidently been used in times of scarcity to reduce hunger, researchers tested low and high doses of hops extracts on people undergoing a 24-hour fast, and found both doses seemed to lower feelings of hunger better than placebo. Might that be a GLP-1 effect? Let's find out. Taking a hops extract before a meal, in either immediate or delayed-release capsules, led to significantly more GLP-1 release than did a placebo. And more importantly, when the study participants were given all-you-can-eat ham sandwiches a few hours later, they ate significantly less. They didn't feel significantly less hungry or more full, but overall still ate about 200 calories less. So a bitter hop extract significantly decreased calorie intake while increasing appetite-suppressing hormones like GLP-1. These changes occurred without the participants feeling any different appetite-wise or liking the sandwiches any less. Now, the extract did make them feel nauseated, bloaty, and barfy, but maybe that's just more evidence it might be working through GLP-1, since those are common side effects of the GLP-1 mimicking drugs like Ozempic. Well, wait, no wonder they ate less. But evidently the degree of gastrointestinal discomfort did not correlate with how much less they ate. The main reason I'd caution against hops is because of a compound in hops called 8-PN that I've talked about before in a 2-part video series. What about quinine? Perhaps the best-studied bitter substance in human history, extracted from the bark of the cinchona tree. Quinine was not only the first effective treatment for malaria 400 years ago, but remarkably remains a common and effective treatment to this day. And give someone 275 milligrams of it, and GLP-1 secretion is stimulated, enough to actually reduce appetite and body weight. Dietary quinine reduces body weight and food intake. In rats, what about in people? Intragastric quinine administration decreases hedonic eating, meaning eating for pleasure even if you aren't really hungry. In this case, a chocolate milkshake. And if you're thinking, well, of course they'd drink less milkshake if they just said something super bitter. But no, the quinine was administered directly into their stomach through a tube, so it bypassed the bitter receptors in their mouth. There are still those bitter receptors in our gut, though, that we aren't even consciously aware of. The researchers even did brain scans and concluded that being unknowingly slipped about 200 milligrams of quinine not only affected how much the study participants felt like they wanted to eat, but how much they actually did eat by interfering with reward brain circuits. You don't have to go lick some tree bark to get it. It's available in every grocery store in the form of tonic water. A liter of tonic water has about 60 to 70 milligrams of quinine, and bitter lemon, another popular cocktail mixer, has about half that. But getting 200 milligrams of quinine still would be like drinking 3 quarts of tonic water. Can we get away with less? Yes, in this study, people were given just 18 milligrams of quinine, or placebo, and then an hour later, everyone was given all-you-can-eat ham and cheese sandwiches, and caloric intake was significantly lower after the quinine than placebo by about 14%. So drinking a third of a liter of tonic water before a meal could reduce your caloric intake by 82 calories. But a third of a liter of tonic water has more than 100 calories, so that wouldn't do you much good. Tonic water is basically quinine-sparked carbonated sugar water. Now, there are sugar-free varieties, or you could go straight to the source. What if you got about the same amount of quinine in the form of powdered bark? The effects of giving about a third of a teaspoon a day of powdered cinchona bark on satiety, weight loss, and body composition in a population of overweight adults. Significantly more weight loss, significantly more waist loss, and even slimmer hips in the bark group compared to placebo. And the weight loss was in fat mass, with greater lean mass preservation compared to placebo. So, in humans, quinine may boost GLP-1, decrease hedonic hunger, lower appetite, decrease caloric intake, and decrease body fat. But there are risks of the consumption of quinine. Quinine is a drug, and may in fact be among the most common causes of severe drug-induced disorders. Just the levels of quinine found in tonic water may cause potentially fatal immunologically mediated hypersensitivity reactions, basically like allergic reactions, where it interacts with antibodies to trigger autoimmune reactions that can cause chills, fever, a drop in blood pressure, painful bluish discoloration of the hands and feet, and clotting within your blood vessels. It can also chew up your red blood cells, leading to anemia, chew up your platelets, leading to bleeding and bruising, and chew up your white blood cells, leading to immune dysfunction, as well as acute kidney injury, the dissolution of your muscles, liver toxicity, heart damage, respiratory failure, low blood sugars, blindness, and toxic epidermal necrolysis, which can manifest as genital blistering, sloughed penile erosion, or an eroded scrotum. Even minute exposure to quinine in common beverages can cause severe adverse reactions involving multiple organ systems, so the moral of the story is that a relaxing gin and tonic may be the cause of life-threatening disease. Now, these are rare idiosyncratic reactions. Just because peanuts can be life-threatening to someone with a peanut allergy doesn't mean everybody needs to avoid peanuts. But there are non-hypersensitivity adverse effects too. For example, when quinine isn't eroding scrotums, it still may be shrinking them. Researchers found quinine so damaging to the testicles of rats that they suggested quinine should be explored as a male contraceptive. Quinine is an extremely toxic agent in overdose, with vision loss as a common outcome. And the reason people may have quinine pills around their house is that some people take them for nocturnal leg cramps. The U.S. Food and Drug Administration concluded that this was not safe, so it banned quinine's use for this purpose in both over-the-counter preparations and even in prescriptions, after receiving hundreds of reports of serious adverse events associated with quinine use, including 93 deaths. It's still available with a prescription as a malaria drug, though, which doctors were prescribing for leg cramps, skirting FDA recommendations, but given its rare but serious allergic-type reactions and risk of ODing on quinine pills, it's probably not a good idea. Thankfully, following warnings by the FDA, the use of quinine for treatment of muscle cramps has dramatically declined. Of course, even though the FDA banned it from one aisle of the drugstore, it still may be available in another, in the form of tonic water. Yeah, but can the lower levels of the drug found in drinks still cause problems? Yes, an overdose can leave you blind, affecting not only the retina in the back of your eye, but the iris in the front, leading to oval pupils. How bizarre is that? Okay, but what if you don't overdose? Can quinine still affect your vision? Following the identification by the Armed Forces Institute of Pathology of quinine in autopsy specimens from military pilot fatalities, researchers had volunteers drink tonic water for 2 weeks, and were indeed able to show some abnormalities. Even transient blurring of vision could be disastrous if experienced by anyone operating heavy machinery at high speeds. So given the concern that tonic water consumption may have contributed to aviation accidents, the use of tonic water by pilots is actually forbidden 3 days before flying. I didn't know that. So how much is too much? There was a case reported of a 46-year-old man with increasing visual deterioration and difficulty with night driving over 3 months, during which he'd been drinking a gallon of tonic water a day. Okay, so a gallon may be too much. This person was drinking a liter of tonic water prior to the onset of his quinine water-triggered heart arrhythmia. His doctors suggest the public simply unaware of the risks associated with excessive consumption of tonic water, but how many people are drinking almost a quart a day? The no untoward effect level in humans has been estimated to be 52.5 milligrams of quinine a day, which is about 2.5 cups of tonic water. Based on ototoxicity, damage to our hearing, maybe we shouldn't drink much more than 2 cups a day, but these levels are based on trying to extrapolate from animal models. Since quinine was so commonly prescribed to treat leg cramps, can we just look at large populations of people and see if anything bad happened? Yes, indeed we can, and those prescribed quinine had a 27% increased risk of acute kidney injury, which is not as bad as death. Association between long-term quinine exposure and all-cause mortality. Following 175,000 people for about 6 years, researchers found that those who were taking about 200 milligrams of quinine a day had a 25% greater risk of dying. Those on around 300 milligrams a day had an 83% greater risk of dying, and those on 400 milligrams or more appeared to double their risk for death. So I would recommend staying away from quinine. Although the FDA has determined that carbonated beverages may safely contain up to 83 milligrams of quinine per liter, bottles of bubbly drinks usually don't say how much is in them, and some popular brands don't even list it as an ingredient at all. How do you know if your drink has quinine or not? Hold it up to a black light, and if it lights up with an iridescent blue glow, well, quinine is the secret ingredient for making fluorescent Jell-O shots.